Okay, this question comes from Math 110. It's a question on the homework. I don't forget what it is, but it's in 6.1, I believe. I'm pulling it in right now. Yes, solve the following system by graphing. And this is the least accurate method of solving systems of equations. If you look in my video on solving systems of equations, graphing is usually the least accurate and least used because of the inaccuracy. The best way is by matrices or by substitution or elimination. So we'll go ahead and do this one. I'll do it best I can with it not being a graphing piece of paper. Let me just go ahead and draw two straight lines up here so I can do that. There's my straight line there and my straight line here. Now, of course, this falls back on what you learned back in chapter 1 and 2, or unit 1 and 2, where you learned the family of graphs, as well as the vertical and horizontal shifts, the steepness, x minus y is equal to 3. Solve for y. Negative y is equal to negative x plus 3. I just brought the x over to the other side. Divide by negative 1. Divide by negative 1. Divide by negative 1. And you get y is equal to negative x divided by negative 1 is x and minus 3. So that means you got a vertical shift of negative 3. This is 1. So that means it's a regular line 1-to-1 ratio, which means a 45-degree angle that's crossing the y-axis at negative 3. So you take your handy-dandy straight line and you go down and you go 1, 2, 3. And there's your y-intercept, and then 1-to-1. And like I said, this is the least accurate, and now you see why it's the least accurate. I don't have a piece of graph paper, so already I'm at a disadvantage because I don't have any graph paper. Second part, solve for y, is x squared plus y squared is equal to 9. That's going to give us y squared is equal to negative x squared plus 9. And y is equal to the square root of negative x squared plus 9. Now this domain is going to be affected because you can't have a negative in the radical. So you're going to have to solve this and see what numbers you can actually put in. So set the denominator, the radicand equal to 0 plus 9 is equal to 0. And that's going to give us, this doesn't look good at all. Negative x squared is equal to negative 9. And x squared is equal to 9 divided by negative 1. And that gives us x squared is equal to positive or negative 3. So x is equal to positive or negative 3. If you plug in positive 3, you're going to get 0. If you plug in negative 3, you're going to get 0. But what happens if you plug in numbers before and after negative 3 and positive 3? So let's plug in negative 4. Negative 4 squared is going to give you 16. With a negative out front, it's going to be negative 16. It's going to give you a negative number. That won't work. If you plug in positive 4 is going to be, that's not going to work. So the only numbers you can use are between negative 3 and positive 3. Let's throw in 0. 0 squared is 0, negative 0 is 0, 0 plus 9. So yes, you can plug in negative 3 and positive 3. So your domain is negative 3. The numbers between negative 3 and positive 3. So you take your handy dandy chart and you plug in -3, -2, -1, 0, 1, 2, and 3, and you plug those numbers in into the formula. So -3, that's going to be a +9, negative is going to be -9, -9 plus 9 is 0. So positive and -3, you're going to get 0. Plug in -2, you're going to get -2 squared, which is 4. -4 plus 9 is 5. The square root of 9 is, I have no idea, 2.7, something like that. So you're going to have a 2.7 here, or whatever the square root of 5 is, and a 2.7 there. Plug in -1. -1 squared is 1, but -1 plus 9 is 8. The square root of 8 is going to be around 2.9. I have no idea, but you can do it on the calculator. And then 0 plus 9 is going to be 3. So you've got two x-intercepts and a y-intercept. You plot those at -3 and 0. Well, here's your line, the straight line that you have with your straight line. There we go, like that. And I'll do this in red. We've got -3 and 0, -3, 1, 2, 3. And +3, 1, 2, 3, sorry, somewhere in there. Let me get rid of that one's just messing us up. And of course, it's not going to work, so I got to delete all of them, of course. So -3 and +3, that may be the point right there. And -2 and 2.7. So -2 and 2.7 is going to be up here, and 2 and 2.7 and 3 and 0 is going to be up here. Now again, we see that the parabola is going somewhere like this, and it looks like to me it's going to intersect at two different points, here and here. Now, to find out where they intersect, you can set them equal to each other. You could try that, or that's algebraically, and the directions are telling you to find it with your graphing abilities. And chances are those are your numbers, but as you can see, you have no graph paper, and no graph paper. If you don't have any graph paper, and you're not using a straight edge to plot your points, you're not going to be very accurate. So that's why graphic representation of solving systems of equations is usually the least accurate.